All right, today we are talking about exploring quadratic graphs. Okay, we did this in class today. This is just going to be a quick run through, refresher, kind of what we talked about. So we talked about the standard form first of a quadratic function is the following form: y equals ax squared plus bx plus c. Again, these are called quadratics because the degree of the variable x is 2, so we call those quadratic polynomials. So this is a quadratic equation, quadratic function. All right, so a is the coefficient of the x squared term, b is the coefficient of x, and c is just a constant. So in example 1 here, we're looking to identify a, b, and c. Okay, so a, the coefficient of the x term is 5, b is 0, there is no x term, as well as no constant, so we say that c is also equal to 0. Okay, identifying a, b, and c will be key for us. Okay, again, if you'd like to think of, well, why are b and c 0 here in this first example we see? Okay, well, we can think of this as y equals 5x squared plus 0x, plus 0x plus 0. Okay, this 0x is just going to simplify to 0. Okay, the 0x is simplified to 0, and it's plus 0. We're not really doing anything. We're multiplying by 0 and adding 0. So we don't really write them in there. And then you kind of see the same thing happening here in this second example, where a is equal to -2, b is equal to 0, but we do have a constant. We do have a c term of +8. Okay. Our last one, you guys should go ahead and try this if you haven't. A equals 1, b equals -7, and c is equal to 2. Okay. So the graph of a quadratic function is a U-shaped curve called a parabola. Okay. The graph we're looking at is y equals x squared. You can clearly see it has a U shape. Okay. But the proper name for these are parabolas. Okay. Don't spend too much time here. You can fold a parabola so that the two sides match exactly this property. It's called symmetry. Okay, the fold line that divides the parabola into two matching halves is called the axis of symmetry. Okay, understanding the axis of symmetry and what it does to a parabola, okay, is important. Okay, it cuts it in half. So if we look down here at this example, the axis of symmetry, well, that dotted line I just drew, okay, wouldn't that kind of cut the parabola right in half? Okay, so our suspicion is that that is our axis of symmetry there, that dotted line that I drew. Okay. From the standard form of a quadratic equation, the axis of symmetry is always, okay, that's a vertical line, so it's going to always be x equals, and then this formula, -b over 2a. That will give you the equation for your axis of symmetry, that vertical line. Okay. In fact, that's drawn here. So for example 2, we want to find the axis of symmetry by observing the graph and from the equation. So again, we've already observed that that line I've drawn is the axis of symmetry. Well, what line is that? That's x equals what? Okay, that is x equals 1 in this case. And that's just from our observation. Okay. And let's see if we can't use the formula -b over 2a to see if we can calculate it. Okay. So a in this case is 1, b is -2, c is -1. We should get used to identifying those pieces. Well, let's now use the formula. Let's use x equals negative, instead of b, -2. Plug in -2 for b, over 2 times a is 1. So -2 is +2, over 2 times 1 is 2. So we got x equals 1. Okay, look, that's what we observed. Okay, so that is accurate. X equals 1 in this case is the axis of symmetry. Okay. It won't be that we always have a graph to look at to identify the axis of symmetry. In fact, a lot of times we'll graph our parabolas by first finding the axis of symmetry, or the vertex, which we'll talk about shortly. So let's, just for this next problem, let's go ahead, let's calculate the axis of symmetry, and then we'll observe the graph and see if it matches our calculations. Okay. So again, we want to identify A equals, well, -1/4, B is -1, C is 3. Our formula again was x equals -b over 2a, so -1 over 2 times a is -1/4. So this simplifies to 1 over 2 times -1/4, that's -1/2. Okay, which 1 divided by -0.5, which will give us -2. So x equals -2. We are suggesting that x equals -2 is the axis of symmetry. Well, let's go observe the graph here. We plotted a vertical line on the x equals -2 line. Would that appear to be the axis of symmetry? Well, absolutely, yeah. Yep. So it looks like x equals -2 is in fact our axis of symmetry. So we don't necessarily have to look at the graph first to identify the axis of symmetry. We can calculate it, well, and then observe that it is. Okay. So let's continue on. I mentioned just a moment ago something called the vertex, so we're going to talk about that now. And the highest or lowest point of a parabola is its vertex. Okay, the vertex, highest or lowest point of the parabola, which is actually on the axis of symmetry. It's where the axis of symmetry intersects the parabola. Okay, a parabola opens upward when y equals ax squared plus bx plus c. Okay, when a is positive. That's what we're trying to get at here. It opens upward when a is positive. And in this case, the vertex is considered to be a minimum point. Okay, it's the lowest point on the parabola. Okay, if we had a parabola that opened up, it would look like that. So it would have a minimum point. That vertex would be that minimum point. Okay, we have a parabola that opens downward when y equals -ax squared plus bx plus c. So here a is clearly negative. And we would have a parabola, a U shape that opens down. So our vertex would be on top, and it would be considered a maximum. Okay, just like we could calculate the axis of symmetry, we're going to be able to calculate that exact point. Okay, how we're going to do that is follow these two steps. Okay, first is to find the x value of the axis of symmetry. So use our x equals -b over 2a. That's going to give us a value for x. Then we're going to plug that x value into our quadratic, into our y equals ax squared plus bx plus c. We're going to substitute that x value in. Okay? And then that's going to give us some sort of y equals whatever. Okay, but then we'll have an x value and we'll have a y value that corresponds to it. So then that'll give us an ordered pair, a point on that graph, which is our vertex. Okay, so we'll practice that. We'll practice identifying a vertex. Okay, just like our other example when we were looking at the axis of symmetry, we could observe the vertex and we could also calculate it. So if we observe this example A here, well, what's the vertex? Let's give me that maximum point. Let's see, 4, 3 is that maximum point. So we suggest that 4, 3 is the vertex. Well, let's see if our calculations work. So again, we should identify A, B, and C. -1/4. I apologize, getting a little sloppy here. Now let me start it back. A equals -1/4. B equals 2. C equals -1. So let's again calculate our vertex. Okay, the first step was to use x equals -b over 2a. That's going to give us that x value of the vertex. And if we observe our graph again, yeah, it looks like that should be the axis of symmetry. So that makes sense. It would give us that x equals, in this case, it should be 4 when we calculate it. So let's see if that holds true. Negative, we're substituting 2 for b. over 2 times a, which is negative 1 over 4. So this is negative 2 over negative 1/2, negative 1/2, my apologies, which negative over negative gives positive 4. So x equals 4. Wow, that's accurate. Okay, that's what we were looking for. We kind of expected. Okay. So the second step for that was to plug that back into our y equals ax squared plus bx. Let's see, plug it back into our quadratic, which in this case, okay, I'm going to highlight it here in green. We haven't used one green today. There. Okay, so we're plugging it into that. Okay, for x. So we've got y equals negative 1/4 times x squared, so 4 squared, plus 2 times x, so 2 times 4, minus 1. Simplifying this, okay, it's going to be important that you guys have scientific calculators to make simplifying these and plugging these values in much easier. So you will need a calculator here. So negative 1/4 times 4 squared is 16, so this is negative 1/4 times 16, plus 2 times 4 is 8, minus 1. Let's scroll a little further. Do some more simplifying. This is y equals, so y equals negative 1/4 times 16 is negative 4 plus 8 minus 1. So we get y equal negative 4 plus 8 is 4 minus 1, 3. And look, we got x equals 4, y equals 3. That's enough to give us an ordered pair for 3. And again, that's our process for finding the vertex. And if you notice 4, 3, again, that's the point we suspected just by observation to be the vertex. So that's accurate. So on this next one, start scrolling there. This next one, let's calculate it and then observe and see if we can't find it. So the process, we need to identify A, B, and C again. We've done that. Okay. First step, use x equals negative b over 2a. So in this case, that's negative 6 over 2 times 1. Negative 6 over 2 is negative 3. So we've got x equals negative 3. Second step is plugging that into our quadratic, our y equals ax squared plus bx plus c. We're substituting it in for x again. So in this case, a1, b6, c6. So we've got y equals x squared, so negative 3 squared, plus 6 times x, which is negative 3, plus c, which is 6. So y equals negative 3 squared is positive 9, plus 6 times negative 3 is negative 18, so minus 18, plus a negative minus 18, plus 6. Simplifies to y equals negative 3. So we've got the ordered pair, negative 3, negative 3. That's our xy ordered pair. And that's what we have calculated to be the vertex. Let's see if we can observe that on the graph here. Well, sure. The point negative 3 is right there. And that is, in fact, the vertex. And the axis of symmetry, if we were wanting to draw that dotted vertical line, goes right through there at x equals 3. Okay, so that's finding the vertex. Now we'll briefly talk A also, as well as having an effect on parabolas opening upward or downward, whether it's positive or negative. The absolute value of A has an effect on parabolas and its shape. Okay? As the absolute value of A increases in value, the width of a parabola narrows. Okay? So the bigger the absolute value of A, the more narrow our parabola gets. And you can see that here. Okay? A is negative 4, so the absolute value of A equals 4. Pretty narrow graph. Here, the absolute value of A equals 1/4. Pretty wide parabola. And our last example, absolute value of A equals 1. It's somewhere between 4 and 1/4. So it's not too narrow, not too wide. Okay. That's all. You got a link here. You're welcome to go check out. Kind of mess around with some parameters. So let's continue on. We want to graph a quadratic function using the axis of symmetry. So and this one has us graphing them on the same plane. In fact, we'll go ahead with that plan. So in red, we'll graph y equals x squared. And we'll graph this one first. So it's kind of messy. So we want to use the axis of symmetry. So, well, what is the axis of symmetry? Again, that is our formula: x equals negative b over 2a. So what's that value here? What's that translate? Well, a here is 1, b is 0, and c is 0. So negative b, negative 0 over 2 times a. Now, that's going to be x equals 0 is our axis of symmetry. So let's come over here on our graph. That's just the y-axis. Let's get our axis of symmetry there. Okay. Next step, finding our vertex. Didn't we? Let's find that vertex point. Okay. To find that vertex point, we've already done that first step, that find the x value. Second step in finding our vertex was plugging that into the y equals equation. Substituting that in for x. So y is equal to 0. So now we've got an ordered pair, 0, 0. That's a good start. That's a point on our graph right there at the origin. Okay. So I'm going to kind of scroll here a little bit. Keep our graph in view there. We've got a point already. Let me get a teacher here. X and y values. We've got a point 0, 0 already. Okay. Let's use our axis of symmetry, okay, which is, again, that kind of reflects over itself, to graph a couple more points on this. Okay. What would happen if we plugged in 1? Well, if we plugged in 1, we could get y equals x squared, so 1 squared, which is 1. So we've got the ordered pair 1, 1 here. What happens when we plug in 2? Well, 2 squared gives us 4. So 2, 4 is a point. So we've got the point 2, 4. All right, well, using the idea of an axis of symmetry, well, ideally if we went 1 to the right and there was a point up 1, well, if we go 1 to the left, there should also be a point up 1. So the idea is there should be a point at negative 1, 1. Well, what happens when we plug in negative 1? Negative 1 squared gives us 1. So that's accurate. There is a point at negative 1, 1. So then, to use our axis of symmetry to plot, we plotted the point 2, 4. We calculated that, found that there's a point there. Well, if we go left of our vertex 2 to negative 2, there should also be a point at 4. That's kind of how you can use the axis of symmetry and its properties to help you graph a little easier. Okay. So let's go ahead. We're going to follow the same process. In green this time, we'll graph our next equation, which was y equals negative 2x squared plus 4. Those are my way. X plus 1. And we're going to graph it on the same plane. This is going to get pretty crowded pretty quickly. Okay. On your homework, you're only asked to graph 1 on each. So we'll graph this one. First step, we're graphing using the axis of symmetry. So let's find that axis of symmetry. Negative b over 2a. Identifying a, b, and c again. We've got a equals negative 2, b equals 4, c equals 1. So this is negative b, so negative 4 over 2 times negative 2. Negative 4 over negative 4. Should have an axis of symmetry at x equals 1. So let's go ahead and draw our axis of symmetry. Well, again, that was our first step in finding the vertex. Our second step in finding the vertex is substituting that value in. So what does that look like? That looks like y equals -2. Instead of x, I'm plugging in 1 squared plus 4 1 plus 1. So this is -2 plus 4 plus 1. Y equals -2 plus 4. It's +2 plus 1, 3. So according to this, I should have an ordered pair 1, 3. That's my vertex. 1, 1, 2, 3. So again, this one is getting crowded. Also, we notice A is negative in this case. So what does that tell us about our parabola? Well, this one should likely, well, it will, open down. Okay. This one will open down because A is negative. So let's go ahead and make a T-chart, get us a couple points going here, X and Y. We've got the point 1, 3 already. I'm going to throw that on there, but yeah, we might as well. So 1, 3, let's pick a couple X values that are greater than that. Let's go 2 and 3, okay? And those points then would reflect to 0 and -1, to the values to the left of our axis of symmetry. Okay? So plugging these in, let's plug in 2 and 3 first. So f of 2 is equal to -2 times 2 squared plus 4 times 2 plus 1. That is -2 times 4 plus 8 plus 1. So -8 plus 8 plus 1 simplifies to 1. So y equals 1. 2, 1 is a point. Okay, 2, 1 is a point. All right, well then, by our axis of symmetry, 0, 1 should be a point. Okay. Let's substitute in 3. F of 3, that's going to give us -2 times 3 squared plus 4 times 3 plus 1. So that's -2 times 9, that's -18 plus 12 plus 1 should be -5. And then -1 should also have a point that corresponds to -5. So 3 down 1, 2, 3, 4, 5. And we go over here to -1, there should also be a point there. Connecting the dots, doing our best to make a U shape. Okay, hopefully you have better luck with that than myself. So that's what our parabola should look like. Okay, I'll go ahead and graph these. I'll graph the green one. Okay, let's see what the green one looks like here first, and I'll leave you guys to graph the red one. All right, so y equals 2x squared plus 3, a is equal to 2, b equals 0, c equals 3. So first step, let's find the axis of symmetry. X equals -b over 2a. We're using that again. So this is -0 over 2 times 2. This should be 0. So 0 is the axis of symmetry, so that gives us our axis of symmetry is the y-intercept, or excuse me, the y-axis. That's our first step to the vertex. Second step is plugging that back into our y equals. So 2 times 0 squared plus 3 gives us y equals 3. So 0, 3 is 8. Let me plot that. Now we got to get a couple values to the right, a couple values to the left. So let's go 1 and 2. -1, -2. Use our axis of symmetry and that property of symmetry to kind of just save ourselves some work. So 0, 3 was a point. Well, let's see what happens when we plug in y. Y equals 2 times 1 squared plus 3. So that's going to be equal to 2 times 1 is 2 plus 3 is 5. So when we plug in 1, we got 5. So let's graph that point. That's here. By our axis of symmetry, there should also be a point at negative 1, 5. When we plug in 2, we should get 2 times 2 squared, so 2 times 4 is 8. 8 plus 3 is 11, so we can have 5, 6, 7, 8, 9, 10. Maybe this one's going off of our graph here. Should be about right there and right there. And we're able to graph those. And those 211, negative 211. We got those by plugging in negative 2 and positive 2. All right, I'll leave you guys to the last red one there. Negative x squared minus 4x minus 6. Hopefully you guys find this helpful.